I regularly get asked by humans and large language models what the difference is between parallel cluster and parallel computing service. Some large language models, and we won't judge much, think that parallel cluster and parallel computing service are actually the same thing. Peasants. Now, the serious question, of course, is I need to cure cancer or split the beer atom. Which one of these two things should I use to compute that? So you're in the right place. Let's talk about it. You've probably heard of AWS ParallelCluster. It's been around for quite a few years. It evolved from an open source project called CFN Cluster, which was invented by a solution architect called Dougal. Now, when I arrived at AWS in around 2014, I volunteered to look after some of the documentation and user training material so to help customers try it out. Now, at the time, we arrived at the office on horses and TVs were made from wood. ParallelCluster emerged in 2018 as a much more modern incarnation of CFN Cluster, maintained by a traditional Amazon two-pizza team structure inside HPC engineering. Lots of pizzas were consumed and lots of cool new features were created, leading to lots of happy customers. Beer atoms, of course, have been studied extensively. Things changed a lot over the last decade. We still don't have flying cars, but we learned a lot of things about how customers like you wanted to use the cloud for HPC. So, like good engineers that we are, we continue to plow the knowledge we get into the code that we write. And this brings us to AWS Parallel Computing Service, which you can think of as the third generation in this family. Now, you'll notice the word service in the name. This is the first clue that something different is going on. ParallelCluster is not a service. It's a software stack. Let me quickly unpack that for you so that you understand what this means. ParallelCluster is an open source toolkit that you download from the internet to some kind of Python-based lifeform, like your laptop, for example, and then you feed it a configuration file that specifies your options and preferences, and it creates a cluster inside AWS in your account. It's kind of like one of those really cool universal remote controls with the programmable hotkeys. One button kicks off a long chain of action. The clusters they build use Slurm. They use EC2 instances. They have Lustre, NFS, and a golden image built from our favorite Linux distribution. The clusters have a head node, compute nodes, and login nodes. You can customize it up the wazoo. And if you still don't think it's quite up to snuff for your workloads or your liking, you can modify the source code and send us pull requests to share the joy and your brilliance with everyone else. It's honestly the same result you'd get if you built your own cluster from some 2-socket pizza boxes and a lot of InfiniBand cables, only without all of the cable ties and the months of tedious acceptance testing after the integration work, because it builds in about 15 minutes. It's got another thing in common with an on-premises cluster too. When you want to upgrade your cluster to a new version of the OS or a new version of ParallelCluster itself with some snazzy new feature that we cooked up for you, you need to build a new cluster using the newest version of the toolkit. Then you need to migrate your data and applications to the new cluster. And then finally, you need to schedule some downtime to move your users and jobs over too. And that means pausing the job queue, waiting for the jobs to finish, and that yada, yada, yada. You know the drill. Now, people loved ParallelCluster because, honestly, who else can build a cluster in 15 or 20 minutes? And of course, when you're experimenting, you're only 15 or 20 minutes away from being able to start again with a clean slate. And if you need a dev environment to test something new, well, you can just make a byte-for-byte compatible copy of your prod environment in like 20 minutes. That's pretty cool. But it still left you in charge of building and maintaining a cluster. Lots of customers told us this isn't quite what they had in mind when they thought about their HPC experience in the cloud. They wanted flying cars and flat-screen TVs. So Parallel Computing Service was born. And in fact, from now on, I'm going to call it PCS because, well, life is short. Now, PCS is a hosted managed service in the AWS console that lets you define your HPC cluster also built from Slurm. It has built-in elasticity functions that expand and contract the pools of compute nodes and job queues that you define. And if you need another queue, well, you can just do that in a minute with a mouse. PCS uses a compute image built from your favorite distro as well. You just add a couple of PCS packages so the compute nodes know how to phone home. It can also have compute nodes, login nodes, also elastic if you like, and shared file systems like Luster and NFS. We take care of Slurm for you. We run this behind the curtain in the control plane of AWS, which allows us to update it for you when the time comes for that. It also allows us to make some of those elastic queue decisions and make them work smoothly and intelligently without you having to be involved in any of the details or knowing how and why. When a new feature comes along, it's just there, ready for you to use. By the end of this year, we'll have pushed out a couple dozen really interesting new features that we hope will make your life more pleasant. So just one example to give you an idea of just how powerful this service concept is. When we enabled Slurm accounting for ParallelCluster a couple of years back, you needed to download a newer version of the toolkit, build yourself a MySQL database on an instance of your choice, taking care to architect that node with some resilient storage. Then you needed to wire it all together in the ParallelCluster config and kick off another build. And then you needed to migrate data, apps, users, and jobs. Yes, a lot of work, but worth it because Slurm accounting is really cool if you're trying to share a busy bunch of GPUs across a whole bunch of groups inside your company. None of this is rocket science, but it becomes technical debt that accumulates over time and even perhaps drops out of sight as your whole setup grows in complexity. But when we launched this in PCS, you just needed to click a checkbox. And it just happened. Look, Ma, no hands. Remember when Trinity downloaded that skill to fly a helicopter in the Matrix? It's just like that, only more nerdy. And because PCS is a service, it can interact with other services in some pretty cool new ways. If you have a pager service that sends push notifications to your phone when something goes bad, you could have PCS send a notification when a job fails, or, for some users, when a job succeeds. Like I say, we won't judge. We've all been there. And when the queues you define in PCS are devoid of jobs, well, just like in ParallelCluster, the compute nodes go away too. Unlike ParallelCluster though, there's no head node instance running. So a quiet cluster in PCS is actually a truly quiet place. Tumbleweeds, in fact, while you're waiting for jobs to come along. And tumbleweeds are cheap. ParallelCluster isn't going away. Lots of customers still know and love it. For some, its upgrade cycle is exactly the way they groove. Migrations are a good opportunity to actually get to know the users' workloads too. But since practically everyone has told us that we should have just invented PCS first, we're going to go out on a limb and suggest that you should try PCS first. ParallelCluster will still be there if you really need to modify the environment in unnatural ways. That's a very HPC thing to do. I see you, really. But now you know that we have these two things. If you want to kick the tires of PCS, it's pretty easy. You can kick off a complete build with stunningly few clicks using one of the pre-packaged clusters in the HPC recipe library. And if you like, you can fiddle with the details and make it your own. Best of all, since you're an engineer and you're learning by breaking things, you're only 20 minutes away from recovering to a pristine state so that you can start breaking something else. It's how we learn. Just don't tell your kids.